Morning. So my name is Nelson Pascoal. I'm going to be talking to you today about GraphQL. Just out of curiosity, who here knows what GraphQL is? Okay, a couple of hands. Has anyone here actually used it in like a production setup? Cool. Okay. Cool. So we'll maybe spend a little bit more time looking at the details then. Yeah, so I've been working as a software developer for about 12 years now. Currently working at a little company called Cloud Africa. A lot of my work's been centered around integrations, software integrations, different systems, different tech, all the way from like text files and FTP directories to myriad of different APIs, some well written, some not so well written. So today I'm going to talk to you about GraphQL. So it's been described as a query language for your API, right? It was created by Facebook. They started using it on their APIs in 2012. And in 2015 it was released as open source. And since then, right, it started gaining quite a bit of traction. So we've had GitHub, Shopify, and a list of whole other places, Pinterest, kind of using it for their third-party APIs. So I like to think of GraphQL as almost like SQL for your API, right? And so before everyone here freaks out that we're going to be, oh my word, it's SQL for your API, there's a lot of parallels you can kind of draw between SQL and what it did for databases and data stores. And there's obviously reasons why it's been invariably shunned by a lot of people in their dev environments. It does have some issues, but I do believe there's a lot of value in looking at the past and how things have happened. So let's have a look at history repeating itself, effectively, right? And how things kind of evolved in the data store world in SQL, and we'll come back to GraphQL, I promise. So, let's go all the way back, right back to the beginning of time there with the data stores, when we had things like punch cards, and bits were kind of represented by holes in paper. So that was pretty simple in those days. You had flat store, sort of single row of data representing some sort of information, whatever it was. It would have been quite interesting to try and debug something like that. I don't know, way beyond my time, I think. So the data media started changing somewhat over time, right? We went from that to your, tape drives, magnetic tape drives, to magnetic storage. I don't know how many of you remember stiffy drives and floppy drives. And as those things started evolving, our data became a lot more and a lot more complex. And we spent more and more time sort of looking at data, transforming it from one format into another, putting it back into the data store, displaying it in some sort of format. And this was kind of like the era of COBOL, right? So you kind of had these COBOL scripts that sort of dominated the world. And actually, ironically enough, I looked up TIOB's index for June this year, and COBOL is still number 25 out of the top 50 most popular languages. So, I was kind of like wondering what these COBOL programmers could look like. You got these like bearded hippie guys sitting in these big banks and corporates. Yeah, probably nothing like that. But that was the closest approximation I could find. Just out of curiosity, does anyone here actually still use COBOL as their like day-to-day job? Nobody, damn. So I was hoping to put some face to that picture, but I guess not. But yeah, so I mean, in those days, if you think about it, like, and if you compare it to a lot of our APIs that we're using nowadays, you had sort of like code running in the database, right? You wanted to change how your queries looked. You had to sort of transform these scripts. You had to have a pretty intimate knowledge of how your databases worked, right? You were pretty much talking directly to the data, playing with the files in the file system or whatever indexes you had, right? And they can, be quite difficult to sort of customize. You had, all these guys kind of doing their particular customized systems. You can imagine like the big banks and things, how that still probably happens to this day. And then around the 70s, a pretty profound thing happened, right? SQL came about. So it was invented in the 1970s in IBM, right, by those two very smart guys there. And SQL gave us sort of a declarative way to request in a database what data we wanted, right? And that's like quite an important point that I want to stress there, the word declarative, right? You no longer had to know anything about the data, you just had to know what it's, at a high level it looked like, and you could declare to the database, or the data store, Mr. Data Store, please give me this information that I'm giving you in this query, and you'd get it back, right? To a large degree, we no longer care what the database, how the database is storing the data, in the intricacy of the bits and the indexes and the algorithms used for all that stuff, right? And this is a great model. Unfortunately, there was quite this, and I'm sure you guys know all about this. There's quite a few vendor inconsistencies in all this stuff, and SQL in one database is not the same as SQL in another. So and even SQL, if you think about it, it doesn't really scale very well when you're trying to get related data. I mean, if any of you have played around with SQL, have you seen how you get a lot of duplicated data out in your join queries? It's very structured, so it's not very flexible in the way that you can get data out. And even like for our environments that we use nowadays, if you think about the rise of things like ORMs, and all these like layers that we're sticking in between to sort of get SQL related data into a format that we want in our apps. So we're spending a lot of time constantly trying to transform data into formats that we want. We want to kind of avoid this, right? And unfortunately, SQL's kind of fell down at that point, I think, personally. And also one of the big things about SQL, I think that we did wrong, was we tried to turn it into a programming language, right? Things like stored procedures and even the ability to inject whatever scripting language into the database and sort of let it run there. So like we're going the opposite way then, we try putting our code back into the database. It should be this isolated box that kind of does one thing well. It's your data store. You can query data, you can transform data, you can get data out. So let's take a step back and look at probably one of the most profound things that happened for all of us here. I'm sure we use it every day, being JavaScript developers, mostly I assume. So the internet exploded on the scene, right? And it was this way initially to sort of do simple HTTP documents, right? You requested your static HTML sites, it was displayed in the browser. And then things like JavaScript started happening, right? Sort of sites started becoming more and more interactive. And you got things like Ajax and single-page apps that started appearing on the scene. And what this did, I think, from an API level, it kind of turned the API from more than just a thing that's used for third-party integrations, right? It became an intimate part of our applications, using things like SOAP and REST, which are probably the two most used ways to create APIs nowadays. That became sort of very central to our apps. And even more nowadays with things like mobile devices, right? But the 3 billion mobile devices in the world today. So APIs became even more critical with the way we talked over the web, right? You've got, a lot of different ways that you can now talk to your API. But is this the best way to do things? I mean, like updates and versioning can be very cumbersome in your REST APIs. I don't know if you guys have come across those problems. I have. It can make very difficult to make general purpose APIs that kind of have the data that everybody requires without it becoming too bloated. Documenting, like we know we've got tools like Swagger and that help, but it can be a bit cumbersome and it can be a bit difficult to keep things up to date. So is there maybe a better way to make more general purpose APIs? So let's have a look at GraphQL to replace these two, our API technologies that we use today. Let's see if GraphQL is SQL without all the bad stuff, maybe. I think there needs to be quite a few advantages if we're going to take something like GraphQL and make it central to our organizations and how things work. So yeah, let's go and have a look at some of the GraphQL queries and things and see how that makes things better. So if you have a look there, so that's a very, very basic GraphQL query, right? So if you look at that, right, so you're saying I want the hero record with ID 123, and I want the ID and name columns out, and all the related friends and their IDs and names out. So if you had an API, a GraphQL API set up with this kind of thing, you would basically get something like that back. So what interesting thing is, if you look there, like GraphQL is actually just a JSON blob without the values, right? It's a close approximation of what data you want. It's a declarative way to request from your API what you want. You don't care about what technologies are in the background, how this data got out. There's a nice clean separation between how your API works and what data your client wants. Another great thing is it kind of helps with the bloated fetches, right? You got one endpoint that you can now modify. You could easily take out the name column and only get back the IDs. If you think about that in a RESTful scenario, right? To get that query out, you'd probably need to do 2 different requests. I suppose in a REST API, you could kind of like return all that data in one query, but then what happens if your mobile device doesn't require that data? Now you've got sort of bloated data going back, too much data being sent back. You're kind of doing compromises from one system to another, trying to figure out what's the best way to do this. So, GraphQL is a great way to sort of let your client decide what data he wants in a nice sort of standardized format. You can also, if you think about things like API changes, right? So what happens if now we decided we're going to add an age column to that, to our data structure, right? So now, how would we handle that in REST? I mean, you could say, fine, for most systems, they won't care that you got that extra field coming back. But if you look at environments like Scala and the more statically typed things, where you've got some sort of struct or some sort of data structure representing what data you're expecting back, that stuff's going to break, right? What if you changed one of the friends columns as well and added age to them? How does that affect the data going back? So in REST, you'd probably do something like versioning, which I've always found to be very, very cumbersome, right? So now you've got like 2 versions of your API, which is kind of like duplicated code, doing different things, and it becomes a bit of a nightmare to manage. So, GraphQL can sort of help manage that, because in your original query, if we go one back, if that's the query that you were sending to the server in your initial API, and you don't add the age column, you're not going to get the age column back, right? It makes it a lot easier to sort of upgrade and evolve your API without affecting your different clients. The other great thing about GraphQL is it's kind of got documentation built into it, right? So as part of like your schema that you declare, you can say, this is the field name, this is the field types. I've got an example of that in a sec. And this is the description of the field, right? And GraphQL can take all that and generate a schema JSON file that you can use to do some really cool things. For example, GraphQL Relay, which is one of the more popular GraphQL clients, can take that schema, and if you're doing something like Webpack where you're compiling a schema literal, so you can declare a schema GraphQL query almost like you would your React components, get compiled down, and it will look at the schema that you got from your GraphQL API, and it will validate your query. So before you even run it, while it's doing the Webpack compilation, it will tell you this query is not valid because this field does not exist, or this filter query is incorrect. You're passing a string and it's expecting an int, things like that. So Facebook's got a pretty cool tool, GraphQL, that they released. So this pretty much takes that exact schema and it builds almost like an IDE for your API in the front end, right? And you can see there, it will give you like auto-completion based on the schema information. It will let you sort of do on-the-fly validations of your data going back. And on the top right, you'll eventually see there, it's got documentation built in, right? So you can go and look up all your fields. And this stuff is just sort of built in. So no more things like Swagger and third-party documentation built stuff to build into your API. You change one of the fields, you update the description, your documentation is updated with it. So I think that's great. Like, it kind of takes all the pains that we've kind of been experiencing and solves it in a nice way. So let's have a look at this. So this is the simplest Hello World GraphQL server that I could find. Okay, so I think this is just one long file. I kind of just split it like that so that we could get the code nice and big so that everyone could see it. But if you have a look there, so you're declaring your schema, right? So we've got a root query type with the different fields. So what you can also do is in the hello there, we've got a type of GraphQL string. So there's certain types that are built in. If you think of that hero example that I put up earlier, where you had a hero with many friends, your type there would be friend, an array of friends, right? So you can sort of have your basic types, and you can also sort of string your stuff together in a graph, right? There's two interesting things we can see from this example here, right? Number one, there's no dependencies on your backend, right? All the different endpoints in GraphQL, there is the mutations, which is for updates, the subscriptions, which I'll show you later, and for querying your data, all come out in a resolve block, right? If you look at the bottom there. So basically, that's the resolve block where you would do your database queries, call another REST API, whatever it may be, get the data in the format that this query expects, and return it back. So there's no dependency on any backends here. It could be pretty much anything. And if you look at the front end, if you think of what transport protocol, most people, when you think of APIs, you think of things like HTTP, right? And there's no dependency here on that. I mean, effectively, all we're doing here is passing the schema that we have, the query to GraphQL, and it's spitting back data. So, I mean, this could be integrated into an HTTP server, like Express or whatever. This could be done through WebSockets, right? If you've got a WebSocket, you could pass a query down your WebSocket and asynchronously respond with the results back to the user. I even saw some examples on the one talk while I was doing research where guys built their own custom UDP protocol to basically talk internally to get data back and forth between the APIs and their different clients. So yeah, if you think of GraphQL, it's just this nice thin little layer with like all the standard query information that you would expect, and you can plug in whatever you want on either end, right? Nice and flexible and sort of self-contained. So I just included the mutation here just to show you what an update looks like, right? So you could, by the way, if you could see, the queries also support comments, right? And so that's how you could basically create an endpoint called create message or create hero. Sorry, that would have been a better word for that method. And you can basically say the name for this new record is BB8 and the age is, I have no idea how old BB8 is. I tried to look it up on the internet, I couldn't find that. And when you're done with that, through the query, return back the ID of the new record. So in one step, you can sort of do the two different things. Subscriptions is an interesting one. That's been done quite recently. And that's basically the ability to subscribe and get updates. So what I'm saying is the input is ID234, right? Again, that depends on your resolve block. So in this case, it could be that when record with ID234 changes, return me back all the related friends for that record. So, you know, again, nice thin little layer. In the front end, you could have WebSockets through which you're doing your subscriptions. In the back end, you could have something like Redis doing pub/sub subscriptions, sort of returning the updates to the front end. And you can push the changes of that record up to the front end. I mean, like, it would be pretty cool to build a little chat app with this, I guess, or whatever else you need to do. So yeah, so I'm hoping that, I know there's been not too much information with regards to how you do the integrations, but like that was kind of, that's pretty much dependent on your environment, right? What back-end systems you're using, how you're dealing with the front-end stuff. Is this the third-party integration with HTTP? I mean, you could even like use this to create third-party WebSocket integrations. That's quite an interesting idea, I thought. So, on to the disadvantages. Well, of course, there's none, right? GraphQL is perfect. Right. So, I mean, it's an evolving system. It's only been around, publicly for 2 years now. So I think, you know, there are little teething problems here and there, but nothing that I consider a showstopper. Two of the things that like definitely stick out for me is there's a lot more initial setup, right? So there's a lot more work to getting a basic little REST API a GraphQL API up and running compared to a REST API, right? Where with REST, you would just need like an endpoint that you're posting to or putting to or whatever, and you sort of do your work and you return back a JSON or blob or whatever it may be. With this, you've got to kind of set up a schema, do all your field declarations, hopefully a description so you can get documentation out, and then it's set up. But, you know, one of the things that I've experienced is there's few APIs that ever remain simple, right? If it's something that you've built that people need, there's going to be new requests. It's going to evolve. It's going to grow. So, that initial setup work, I don't know if you call that a disadvantage really, but it's more like that's something that we should always be doing with our APIs to make sure that we foolproof them for, future growth. The one thing that's quite interesting that's come out is caching, which has turned out to be a bit tricky. If you think about like any of your REST APIs, you usually have an endpoint, and you can sort of like guess if this is the query information going into my request, this is the data that's going to come out, right? Barring any updates on the server side, like you could probably cache that for 5 minutes. But in a GraphQL query, the queries going through that same endpoint are different. They could change the fields that they request. They could set different filters. So the API caching can be a lot more tricky in this case. So you've got to give a little bit more thought to how you cache data and how you're going to handle the different requests. I suppose you could maybe just cache the entire data and then just filter out the fields that the user requests, which can be a little bit wasteful. But yeah, it's early days, so it's be interesting to see how people sort of solve this problem. The other issue is, of course, if you've got like a big API already set up, the advantages of converting that to GraphQL would obviously, outweigh the disadvantages of writing something from scratch. So if you've got like a big JSON API set up with all the nice structures that gives you, probably that GraphQL is something you might not want to consider just yet. So I think that GraphQL is definitely progress. It's not perfection, but I think that's kind of like how we do things, right? And it's like the new technology. When REST came out, REST was great. Everyone jumped on the REST bandwagon. We started building these massive APIs. And we eventually found the pitfalls, the problems with that as the systems grew. So I think the same thing is going to happen with GraphQL. As things go, as people start adopting this technology and start using it, building massive systems with it, we are going to find little pitfalls here and there, and things will evolve. So let's hope that GraphQL doesn't do things that SQL did with trying to make it into a programming language. I think GraphQL has a very narrow sort of like area that it's good at. And let's hope that it stays in that section and gives us the flexibility that we want for the future. But yeah, so I think GraphQL, and maybe there'll be other systems like it, is definitely part of history in the making. And that we'll, let's see where this goes, and let's see if we can learn some lessons from the past and apply it to our future. That's it. Thank you. Yeah, sorry, just for the video. So the question is there anything like adapters that kind of let you plug into a database, like your data store? Again, I suppose that's very like environment dependent. I haven't really found anything yet. Because it's kind of just, I think GraphQL was kind of just focused on that like little API layer, right? And it's got those resolve blocks. So I suppose that's something that will evolve over time. People will kind of see, hey, Mongo, this might be a nice little thing to build for it. I know in Clojure there's the Senior, which being a graph-based API, it fits in quite nicely with something like Datomic. So they're kind of like trying to kind of gel the two together. But yeah, it's an evolving area. But the great thing is, with the resolve blocks, you're not limited with like, oh, I don't have a driver for MySQL or whatever it is, and I can't integrate it. That gives you that flexibility. Yeah, that's an interesting point. So security and authorization for your API. I suppose you could look at it in the same way you would look at REST, a REST API, right? If a query comes in on a REST endpoint, you'll authorize it with basic auth or OAuth or whatever you're using, and based on that, you'll filter the data that the user can see going down, right? So if he requests an account that he doesn't have access to, you'd return the appropriate response. And because GraphQL has like that relationship, I didn't show it in the query, but what comes back in those resolve blocks is a context. So if you imagine you're starting at account level, or like let's go back to that hero example. You're starting at the hero, I have access to hero ID 123, I want the related friends. In your environment, you'd know, okay, this is the context that I'm getting through, is this user, or this hero, sorry, so only show these friends. So you kind of have to, like, at the top level, whatever auth layer you're using there, use that to sort of filter the query down and restrict that way. Yeah, again, so how do you differentiate between different HTTP requests, like post, put, and get? That kind of stuff, again, GraphQL doesn't care about that, right? If you think about it, it's that thin layer, right? Like that example that I showed. If I can go back. Is that the right one? Yeah, there. There's no API here. There's no HTTP in this example at all, right? So generally, I think the standard is to use post requests. So you put the query in a JSON block, saying query and then your query string, and you post that to the API. But there's no restrictions on that, right? I mean, this could be a WebSocket. What if you're doing it through a WebSocket? Then get, post, put, delete doesn't really make sense in that environment. So yeah, it's like kind of agnostic from that. So the RESTful, CRUD stuff doesn't really apply to GraphQL in the way it works. Yeah, so like how does the client know how to get to GraphQL? So basically you have a /GraphQL, that's kind of the standard, that an endpoint in your API, like in example like with Express, and then your clients kind of know about the standard ways to request schemas, like that GraphQL example. You just tell GraphQL, here's where you're going to load up, and this is the endpoint where GraphQL API lives. And it will query out the schema based on that and get whatever information it needs. I hope that answers your question. I believe TypeScript support, I believe there is. I mean, it's all like all the Facebook stuff is JavaScript. So the most of the libraries that you get is JavaScript based. That's what Facebook released. So I'm pretty sure you could probably call it from TypeScript, but the libraries are all written in not TypeScript, in JavaScript. Yes, sure. Yeah, I'm not sure, to be honest. Yeah, but I'm pretty sure there's probably somebody that's built something like that by now. Yeah. So there's a couple of different libraries you can implement it, like the Licinia closure library. It's got its own like EDN notation, which is basically mimics that schema, but in like a closure EDN environment, right? But you do, the GraphQL recently released a thing called schema definition language, which is like a generic way, like a text file that says, this is my schema, and then you just basically hook in, like, for this query type, this is the function you need to call, and here's the resolve block that you must execute. So there's that kind of like standardization, that they've been trying to implement. GraphQL. So if you think about the structure of the data, right, it's kind of like a graph. If you look at that, right, you kind of like, it's a graph way of looking at data. So I'm getting out a hero and find all the related friends for this hero. And you could like, I mean, the one application that I used for this, I had like about 5 or 6 different nested levels. It was like a complicated ordering system with a lot of like related data, and you can just like keep nesting that and going down and getting the queries. Of course, like I've always wondered if it's possible to get this thing into like an endless loop and confuse it, probably. But yeah, I mean that's kind of like, it's sort of like going through the graph of your data. You structure your schema you have your query root endpoints, and it structures down that way. So GraphQL, a graph querying language, if you will.